started. Up to now, we've done our weight and balance, made sure that we're legal to go, don't need an alternate. Everything's good so far, right? So, pull out my stuff here too. It's a mess right now. I promise you, I'm never this disorganized as far as like all this junk. Let's see. Okay, so now we're on to finding ISA at our origin airport and then figuring out our altitude, right? Is everybody up to speed? Feel ready to go? Okay. So who remembers how to find ISA, our ISA deviation?
You would get it from your winds aloft chart,
Okay.
and based off of the temperature of wherever you're going, you would either move right or you move to the right or to the left, and it would be like plus 4 degrees Celsius or minus so and so degrees Celsius off of that ISA.
Yeah.
Right?
Yeah, so that's en route, right?
Okay.
We'll go off our winds aloft chart, but for Seattle, we've got our temperature right there in the METAR, right? Our current temperature. So we'll just use the current temperature in the METAR and we'll find our ISA deviation. So let's pull up Seattle's Jeppesen chart really quick. Oh, good catch.
I guess don't forget to record.
Oh, it's already recording.
Oh, okay.
I got that part.
All right. I'm like, are you recording?
50% today. Almost had it. Okay, so what we're trying to do here is we're just trying to find what elevation our airport's at, right? So our elevation, you can see here on this chart. So this is just your like the AFD type chart, but this is the airport description chart. So if you look at the end of the runway, it gives you an elevation, right? 356, 347. On this side, it's 415, 430. So we'll just say that it's like 400 feet above sea level. Everybody good with that?
Okay.
So 400 feet above sea level, what's our ISA deviation? Or what's ISA at our airport elevation? So we got to figure out ISA first.
Isn't it always 15 degrees Celsius?
So at sea level, so ISA, okay, at sea level, MSL, it's 15 degrees, right?
Yeah.
So what is our ISA at Seattle if our altitude's 400 feet?
Altitude's what?
400 feet. So we're 400 feet above sea level. So yeah, we'll just round it up to 500 degrees or I mean 500 feet and take off 1 degree because our lapse rate is 2 degrees per 1,000 feet, right?
So since you're going down, oh, I know.
So this is at Seattle, 14 degrees, right? Are you good with that? You have a question?
So I know that it's 2 degrees every 1,000 feet.
Mhm.
And so at sea level, if it's 400 rounding 500, you would just divide that in half, so 500, so 1 degree.
Right.
And since, so you would take 15 and you go to 14 because you're going
Yeah,
lower
so
than sea level?
every time-
Or-
Yeah, so here's sea level. Let's just say this is sea level.
Yeah.
Okay? You got a mountain here that's 1,000 feet tall. Okay, sea level, here's 500 feet, here's 1,000 feet. At 1,000 feet, we drop 2 degrees. So it's 2 degrees colder at 1,000 feet, or if we're going standard. But at 500 feet, we drop 1 degree. So you can just minus. Now let's say that we're in the Dead Sea over here, and your elevation's like minus 500 feet. It'd be 1 degree warmer down there, right?
Okay,
Does that make sense? So
yeah.
as you climb in altitude, you're losing, it's a minus 2 degree per 1,000. If you're going below sea level, it gets warmer.
Yeah, I just always thought you always made it 15 degrees Celsius based off of wherever you were at on the ground.
Nope. Remember our standard temperature and so standard temperature and pressure is 15 degrees C at sea level, or 29902 is our standard pressure. Yeah. I'm trying to think. Okay, so that being said, we're 14 degrees. Would be our standard temperature. So what's our deviation from ISA? Look at our temperature now and figure out our deviation from ISA.
Is that 15 the one you're talking about?
Yep, so our temperature right now on our METAR is 15 degrees.
Okay.
So we go 15 degrees right here, right? ISA is at 14 degrees if we're doing our little number line here. ISA is at 14 degrees. So
plus 1.
Yep. So it's 1 degree higher, so it would be ISA plus 1 degree, right? That's how we would write it. ISA plus 1 degree, because it's 1 degree warmer.
ISA deviation plus 1? Or
No, just ISA plus 1 is our ISA deviation. So ISA is us just talking about the airport or the elevation that we're at. ISA deviation will be the deviation from standard temperature. So we always penalize, right? Because what we're doing with ISA deviation here is we're basing our performance off of it, and we'd always rather be safe than sorry. So we always do it in 5 degree increments on our performance charts. So we have performance charts for ISA minus 10, ISA minus 5, ISA, which is just, right? And then ISA plus 5, all the way to 20. So does that make sense? So what we're going to use on our performance charts for Seattle Airport would be ISA plus 5, okay? And I'll show you why when we look at this chart.
Because if it's
ISA plus 1, and it's ISA plus anything, you're going to be at least plus 5.
Yeah. Yep. So if you're above ISA, you always want to go warmer. That if it's between the two numbers. Now, if we were at ISA, we would just use the ISA chart. But since we're warmer than ISA, never round down, always round up. So if we come in here to our flight planning stuff, we can get our, there's this section here, flight planning altitude selection, okay? Excuse me. We're gonna use this spaghetti chart here. You guys remember using this chart? Last, what was it, 2 weeks ago? Anyways, okay, so what we're going to do is this chart is I'm trying to think of how to be able to write on this. Okay, I remember now. Okay, so this chart, when we look at it, this is picking our altitude, our cruise altitude. So across the bottom here, we have our gross weights, which we figured out on our weight and balance chart. And then these are the flight levels, okay? These lines right here are the temperatures in ISA deviations. So we can see that we have a line for ISA plus 20, ISA plus 15, and ISA plus 10 degrees and below. So this is the best performance, and it gets, as you can see, as it gets warmer, our altitude capability gets lower. The reason why it stops at 10 degrees C is that the max altitude on a CRJ is like 39,000 feet, I think, for the 700s. So that's why we stop there, because there's no point in going higher. So pull out your weight and balance charts. And what was our gross weight? What was our takeoff weight? Takeoff weight we call MTOW, right? MTOW. 68 what?
62.
62,833? 63,000 pounds. Okay, so we come here to our gross weights on the bottom. We go to 63. We'll take that all the way up here to our ISA, we're ISA plus 5. We'll take it to our ISA plus 10 degrees C here, and then we'll follow that over to this side, and that gives us our altitude. So everybody get it? Understand? So we are just below 41,000 feet, which means we can't go up to 41,000 feet, so 40,000 feet would be the max altitude we could even plan for.
Is that just how high you can go just in general, or?
That's what we're going to base our performance off of. So that's what we want to cruise at. That's where we're going to get our best performance, is at our altitude capability. The higher you go, the less wind resistance. Remember in class and I wish I had a board that I could do stuff like this in class, but so think of like a tube or a cylinder. Okay, you've got this cylinder and it's full of air. Well, let's fill it up with feathers. So you start throwing feathers in here. Down here at the bottom, as you continue stacking feathers on top of each other, the concentration of feathers is going to get a lot heavier down here, right? But as you go up the jar here, they get less and less, right? Because the weight of the feathers is pushing down the ones on here, which concentrates it more. Up here, they're just light and wispy. So they suspend a little bit better. but down here it's really dense. It's the same thing with our atmosphere. If you were to take a cylinder of our atmosphere, the molecules are compressed more down here at the surface than they are up here at the top. So if we can get up to this in our airplane, so here's our little CRJ, if we can get up to that altitude, there's less resistance, less friction, so we can cruise more efficiently. So, that makes sense? Okay. So we've found our altitude that we want to use. What was our fuel that we decided to? I'm just going to do our estimated here. Estimated fuel. You guys remember the burn?
5750.
5750. Okay. And this is what I do on my chart here. Or not on my chart, on the back of my paper, is I'm writing down all these numbers. I also make a graph kind of like this, and I can start populating this site. So this site I consider my origin or my departure airport. So that's Seattle. Okay, and we know, so we don't ever have to come back and calculate Seattle's ISA deviation again. We're going to put ISA plus 5. Okay, we've already calculated it. Don't go back and calculate it again. Just write it down so we have it. Okay, we've got our estimated fuel up here. Our cruise capability. Okay, you can write it right here. So this is, we call this top of climb. Okay, top of climb. And we can put an altitude here. So altitude that we are capable is flight level 400. Everybody good with that?
What's the letters TOC?
Huh?
What's the TOC stand for again?
Top of climb. Okay. This side would be top of descent, so TOD. And then this is our destination. Okay. So we can put San Francisco here. Okay. So now that we have our altitude, I'm going to kind of clean that up a little bit. Okay. We're just going to start filling in all the gaps here. We're going to do like a simplified fuel. And a couple others. We'll get to that point. Okay. Now that we have that, we can figure out our data for our climb out. So once we've figured out, or actually first we're going to want to do our simplified flight planning here. Okay, so we're going to want to adjust. Yeah, we're going to want to adjust our estimated fuel burn and weight here. So what we do now is we're going to go to Sky Vector here. We've got our flight plan in here still. And we're going to get our average heading here. So what we can do is we can do that. That gives us an average heading, right? So I'll write on here, average heading is 164. Okay.
Is that something separate or are you going based off of that graph?
Huh? This is separate from the graph. This is just other information that we're going to be writing down here. And our distance is, once I put this back in here, our distance is 632 miles. Actually, just put nautical miles here. Okay. Everybody good with that? Now what we want to do is we want to get our winds aloft. Now that we know what altitude we're going to be cruising at, if you look here, the max altitude here on this chart is 39,000 feet. And we're going to apply that to our, we're going to find our average wind direction, heading, and our average temperatures for cruise.
At 40,000 feet.
Yeah, so let's figure out what we're going to cruise at, because we are capable of 40,000 feet, but does that mean we are going to fly at 40,000 feet? Okay, you guys remember what my acronym is for
Sweden.
Neon Sweden, right? So northeast equals odd altitudes, and southwest equals even. Oops, not even. Even. Okay. That being said, what is our average heading? We're flying
We're going south.
164, right? 164 degrees. So what is that?
So we're odd.
Right. So that is southeast, right? So
North, not west.
right. So northeast, that's saying from 0 degrees, and then following this compass down to 179 degrees.
Is odd.
That's odd altitudes. Okay. Then from 180 degrees, following this compass around to our 0 degrees, we fly at even altitudes.
You know, I always thought that was like just VFR.
Nope. Everything. So we're at 164 degrees, which means we're somewhere right here, right? Which means we'll be using odd altitudes. So although we're capable for 40,000 feet, we're actually going to cruise. Our cruise will be flight level 390.
Is that just to prevent
Yeah, exactly. If you're flying in these directions and everybody's flying odd altitudes, you'll never have a head-on collision. Does that make sense?
So Garrett, is there a reason why you went down instead of up?
Yeah. Because our, going back to our cruise capability chart, we are only capable, if you follow this up, from the 63,000 pounds, the highest altitude that we could do would be like 40,700. So since we can't hit that 41,000 feet, we got to go down. Good question. Everybody good? Feeling good? It's a lot easier than Yeah. So now that we know that, let's go to our winds aloft chart. Remember, 39,000 feet is the highest reporting. And we're going to find these little dots here, these VORs. So let me slide this screen over a little bit. We've got Seattle, Portland, Redmond, Red Bluff, and San Francisco. So let's find where these are at. So at Portland VOR is right. It's right here. Okay. Well, this is Columbia, but let's see. If we switch to low. Anyways, maybe it's Portland International Airport that they're. So Portland International. This is the winds and temperature aloft. Not too far south of Seattle, so we're probably going to still be climbing to 39,000 feet. So at that point, it's just interpolation, right? So how high do you think will be? Just throw a number out there over Portland. 27. Well, so yeah, probably somewhere in there. It's like a total of, I don't know, 102 miles. No, 65 miles. So you're probably halfway through your climb, about. So, anyways, we know that we're going to be climbing, so let's not worry too much about our IC deviation during climb. Let's find our IC deviation at cruise here. Okay. So let's go to Redmond. Okay, Redmond, oops, is right here. It's hard to. It's right next to Deschutes here. And that's a pretty good clip away from Seattle. So let's just say that's where we're going to be pretty close to our top climb there. So we'll use Redmond for our average ISO deviation. Okay. And then Red Bluff. Let's see where Red Bluff is. RBL. So Red Bluff is right there. That's going to be pretty close to our top of descent, huh? In fact, it is our transition point. So we're going to probably be starting our descent around there. So we'll use those two VORs for our winds and temperatures aloft to find our average during cruise.
What
So,
VORs are we using?
Redmond and Red Bluff. So RDM and RBL.
Because I don't know why I have Lakeview here.
You've got Lakeview on your.
Yeah.
I was going, I mean, that's a VOR that I have, but
That's
Oh,
what you
yeah.
have too, Garrett.
I just don't.
Oh yeah,
Lakeview and
Lakeview's right here. So that is our transition point. That's our transition point for our star. Or not our star, our SID. So since that's a transition point for the SID, that doesn't mean that it's going to be our top of climb. We're using these winds aloft here for finding our average wind speed and temperature at an altitude. So we just grab a couple off of the winds aloft chart. If you guys want to see what the Let's pull up the wind, what it looks like when I don't edit some of them out.
And they are gonna vary, all of ours will vary a little bit, like when people are.
Yeah. Yeah, it's all, remember, interpolation. So there's going to be, you know, a couple 100-pound variation between people's flight plans as far as fuel and total weight goes. So, um, let's see, find it. It's not the one I'm looking for. There we go. So I just edit a bunch of the VORs out so that you guys are getting the information you need. You don't have to hunt and find every single one of those VORs because that's kind of a pain. We do have Lakeview down here, but this is different data than when I pulled it. So, and I think 2 or 3 points is good enough to get on this short of a flight, good enough to get a good average. So if we come over here, we've got our 2 winds and temperatures aloft, and we're just going to find the average of those. Okay, so how do you find averages? We'll take all of them, add them all up, and then divide by the number of temperatures, right? We all know how to do averages here. So it's pretty easy when you only have 2 and they're that close. So 24 degrees, or I mean 240 degrees, remember? 240 degrees for our wind. So this is our average.
So, would you 240 degrees that again?
So we're looking at the winds aloft chart there. And do you see where I have the red box at?
Yeah. So you're saying 240 degrees because it's between 25 and 23.
So 240 degrees at what's the average between 35 and 42? That's, let's just say 38 knots. You're the math guy. Come on.
I was looking down. I didn't know. I didn't know
It's
my own.
38.5, so you can just
So-
go up or go down.
We'll just say 38. 38 knots. Okay. Does everybody understand where I got those numbers?
No, I was gonna ask you,
Okay.
28, or wait, what, 32 and.
Okay. So winds aloft. The first 2 digits are going to be our wind direction. We add a 0, right? So 250 and 230.
Oh, okay.
Okay. Our second 2 digits are our speed, right? So we've got 35 knots and 42 knots, right? And then the last 2 digits are our temperature. So our temperature here
Negative.
is, yeah, after 24,000 feet, it's impossible to get a positive temperature because of the lapse rate. So we know those are negative 62 and negative 64, right? So the average between 62 and 64 is going to be 63 degrees C, negative. All right. Does everybody see it?
Yeah, sorry.
Okay. No, you're fine. Okay, so now that we're doing temps, winds aloft forecast, what if I have a winds aloft forecast that says, so what if I have that? You guys remember this?
Exactly. 50 from close to.
Yep, so we subtract 50 from 77, minus 50, and that equals what? So that's our first number is 270 degrees, right? 270 degrees. We add a 1 in front of this, so that makes it 154 knots. And then a negative 52 degrees. Good? Glad you guys remembered that. What if it's a 9900 winds call? Light variable.
Why would they put 7.7 again?
Because it's a speed greater than 100 knots. So it's always going to be 6 digits or less.
Speed, the next.
No direction.
What was that?
The direction is, because you can't go faster or in the direction is greater than 36.
Right. So the reason why they do it is if you have a speed of 100 knots, so let's say it was like 27, and then they put 154 and then 52, that light errors out on the computer. It wouldn't work.
Digits.
Yeah. So they eliminate this digit and they put it there. To indicate that you have wind speeds greater than.
So your wind is 154.
Yeah, so your winds are 270 at 154 knots minus 52 degrees. Everybody good? Okay. So I'm gonna keep that confusion there. We'll take some of this stuff off so we don't.
For practical, how many flight plans will we be doing? Does it?
One.
Oh,
Yep, you do one flight plan. Greg, I believe he has like 10 plans, and what he does is he just draws a number out of a hat before he even shows up. And then, or he'll lay out 10, like just a number 10, or he'll number them 1 through 10 and say, pick a number, and he'll just give you whatever number you pick. And he mixes them up. So. Don't conspire with each other and try to. No. He mixes them up. So yeah. So everybody pick number 5. No, just teasing.
It's kind of like Spies Like Us. I watched that someday just for kids.
I haven't seen that in forever.
And when he's going in to take the Forest Services exam,
Yeah.
Foreign Services reminded me of going into that test. The camera's open. Jeez.
It's yeah. So we've got our average winds and temperature. We have our average heading. We have our distance, estimated fuel. So let's figure out simplified. So here comes the spaghetti charts. You gotta love it, baby. So the way this works, the way these charts work, is you have along the bottom here, you have your trip distance, okay? There's 2 charts, And that's why you don't see anything over 500 miles here. So you got to make sure that you're on the right chart. And here we have our 500 and greater chart. Okay. So the way we find our fuel burn, this part sucks. We got to go here on our spaghetti charts and figure that out. So we always start on the bottom with our distances, okay? Then we work our way up and then to the right on these charts, okay? So this chart, we find our miles here. So this would be 650 at this point. We know that we're at 632 nautical miles. So you can see these faint little dots here. 1, 2, 3, 4, 5. So 632, we're going to be about right there, right? I wish there was like a line.
So you just make a straight line.
Okay. Ah. So we're going to go straight up from this line, and we're going to end up on this line about right there, right? Everybody good with that? So we come up to our reference line from the bottom there. Trying to draw straight on this thing. Okay. Now we can eliminate that. Maybe. Arrow. Can you eliminate that? Okay. Now you can see these little wind lines, right? These wind lines are just reference lines here. Okay. So what we're going to do is we're going to find out if our average heading is 164 degrees, what are the winds doing to us? Are they pushing us along, or are they, headwinds and slowing us down? So you have these awesome tools on the internet. Not those. We call them crosswind calculators. Okay. Let's see if we can do it. So what we'll do here, instead of runway numbers, we're going to put in our average course. Oh, this one might not be good. Let's find us on your calculator, there's one.
I don't know how to use that.
I know. Well, I'll show you how to use it right now.
So, aviation.
Yeah, so this is an E6B flight computer. So everybody just look up on your phones, look up VFlight Calculator and download an app. I don't know what app Adam's been recommending. I've always used I've got one of these as well. So yeah, so what you do is you come to
Wind.
wind, and the X/H wind. Okay, our wind direction is 240. Okay, we hit down. enter. The wind speed is 38 knots. And then our runway. And that tells us on the bottom there.
29.
So there's a 29 and then a minus sign, so minus 29. So if it's a minus, that means it's a headwind. Or,
Plus it'd be a headwind, wouldn't it?
so the Aero Data software at work is throwing me off here. I gotta draw this out. Okay. Did somebody download the calculator on their phone yet?
Yeah.
You got one?
Yeah.
Okay. So, wind speed,
38.
38 knots. So, okay. Now do your, or done. Okay, now do your wind direction, 240. Oh, you might slide it on the bottom there.
Okay.
Okay, go to 240. Okay, and runway number 16. 16, right.
So
Headwind is
6.6.
something happens on,
Yeah,
Yeah.
and you have 6.6,
let's see real quick.
37.
and I can always use 2.
What'd you get? I don't know how to figure this out. Did you demo this one?
Do you recommend
Yeah,
starting that
So
when we
the
start
crosswind
working
is
there?
38.
So Android?
What was that?
I'm just thinking in my head here.
Huh?
Do you recommend us having that calculator when we get
Yeah.
hired?
Not when you get hired.
Kind of feel like this.
Computer does all the work for you.
Okay, and you can use, if you're gonna be here, you guys can use it too. I mean, the problem is I don't know how to use it, but you can, you can use it.
So,
There you have the Zoomers and apps too, I just don't know which one I should know.
Yeah,
6.
because I did use it just,
No, I didn't remember either.
yeah.
I
Somebody
downloaded. I just picked one.
You just pick one,
I don't remember.
are you Apple or Android?
Android.
Okay, so if you just hit enter and go back down to your runway,
Usually
we
if you
do
let
16,
it slide,
164.
it'll
It's
release
for
something.
actual runway number.
See if I see that one. Okay.
Okay, so the minus is a headwind because it's negatively affecting us, right?
So what was the answer?
So our wind, our average wind, so with our average winds, it's a minus 6.6 knots. So a 6.6 knot headwind.
Yeah, that's what.
That's why, is because I hit 164 instead of 16.
Yeah, and I was wondering if that 164 was the average.
Yeah.
160.
So did you guys download the app too, or a app?
No,
And added.
You got one? Or?
That's for runway, wind speed, wind direction.
Yeah, so
That's what I want.
the runway, just think of that as your average heading. So
Oh,
164. So 16 will be your average, or you'd be on runway 16.
I got you.
It's my password.
Then wind direction, 240. And then your speed is 38 knots.
It's a circuit direction, left or right.
Just calculate, I don't know why that would matter.
Headwind 7, so 6.6.
So
Yep.
is it not gonna give me that in negative, or do I just need to know that?
No, so it's just on her calculator. This one tells you headwinds or something. So if you were to adjust the runway number, it would tell you.
So if it's negative, it's a headwind,
It's
if
only
it's
gonna
positive,
be
it's a tailwind.
every 10 knot.
Yeah, that's fine.
Mine doesn't tell you that, you just have to use
Which one?
the headwinds.
I don't even know how to use this.
The one that's free.
Headwind is
Yeah,
a
it says do it.
Okay, so-
And then
So open that out, so do your heading,
240 or just
Smarter than that.
for your.
Okay, so
I'm not smart.
Your heading
Like,
would be
you know what, I
16,
bought it from
160.
ATX, because you know, they're asking
that's
us
the
to do all
heading you're
these
going.
things. I
So
do none.
adjust your heading to
I just use it
16.
for one function, I don't teach myself how to use it. I mean, it's-
Your wind direction, go to 240,
Yeah.
Yeah, I got most of the charts.
and your wind speed go to 30
So, the
knots.
fact that it's, we're at 164, I'm gonna add this one, there's 164. The wind is 240.
Okay. Right there, headwind, 70 knots.
Right.
I don't know why
And it's a
it
right
asks for
crosswind.
that.
So your crosswind component would be 37 knots, but we don't care,
If you were landing,
um,
what number?
because we're not landing. Basically, what a crosswind component would do is, and it's going to be calculated out when we're doing our actual legs.
Okay.
But a crosswind, say that it's a 37 knot wind. Instead of flying a direct course, we have to adjust our course for the wind.
Because it'll push us.
It's going to be pushing us, so we have to crab into the wind. But that'll all be calculated when we do our legs.
So for this chart right here that you have up right now,
Uh-huh.
the bottom is 100, but what if your wind speeds are over 100?
It's Armageddon. I don't know.
You just don't fly.
Yeah, I think you just take it down to the bottom here, and then you just bring it up. In all of my flight plans, I've never had an average headwind or average tailwind of more than like 50, 60 knots. So, not saying that it doesn't happen.
Just curious.
Yeah. So now that we know our wind speed and we know that we have a 6-knot headwind, right? So what we're going to do is we're going to follow the contour of these dark lines here to 6 miles an hour. Remember, these black dots are 10 miles an hour or 10 knots, right? So if we follow that basically to the first dot, that's where we're going to go up from. So I'll show you here. So we come here, there's a dot right here. So basically we're going to be somewhere about right there when we start coming up on the graph here. And we'll just follow that up to, you see right here on the chart, it says flight level 370 and above. It's pretty small.
Can't see it, it's tiny.
So we're going to print out these charts, or I would ask you to print out these charts. The file online here.
Do you want them all?
No, it's 43 pages.
Right.
Oh, gosh,
That'd be like, oh. This is a lot more than just that, though.
How many do you need to have? Of just this chart or all of?
We'll need most of the charts. Some of it's more just like text, and you don't need the text section of it. But you will need all of the performance charts. There. Basically, yeah, you probably need 43 pages.
Okay.
That would be like $7. It's not too bad.
Not for a textbook.
Huh?
It's not for a textbook.
Yeah.
Oh my gosh, it's so small.
So on the chart here, it's a lot easier to see.
Something.
I can bring the chart around to you guys and just show you each one at a time here.
Can you zoom in on the screen?
And in real dispatcher life, we won't have to do it as you're saying, right?
Right.
Okay.
That'd be a lot of work, fun exercise.
Yeah.
You click a button and it goes, oh, here's your performance. All right, thanks.
Lovely.
Okay, so, in case there's like a malfunction within the system, do you have a backup like these?
We have a backup center, but say like all hell broke loose and it shut down everything and our generator wasn't working, rather than go and try to figure it all, have hundreds of people in a room trying to figure it all out on charts, we just shut down the airline.
Everything cool.
Do you have much of that?
Cancel.
So this is the chart. You can see right there, flight level 370 above. It's not much better.
Yeah, no one's.
Yeah, just took the-
You guys can pass it around.
Because with the AVX, they give you the clear plastic thing to write on.
Yeah,
There's 2, 3 of them on there.
yeah.
But it's hard to figure out these charts, even, I can't get them accurate.
It's, once again,
I'm just glad they showed an example arrow and how it flows. That made it a lot easier.
yeah,
Follow the arrows.
exactly. That's the good thing about the charts is usually there's like an example. I don't know. You guys see that at all?
That's not even good.
I know it's clear.
It's a clear.
I know.
Killing.
But you can kind of see the shadow if you're up close, I guess.
Here, just use my marker.
I don't think the school will like that.
Yeah, they come in the morning, read all the performance charts embossed on their screen.
Yeah. I was thinking about using a dry erase, but I don't even want to try it. Okay. So we've come up from 632. We came to our reference line, which puts us about right there. We go up to our 6 knot headwind and then come up to this line here that's 370 and above. Okay. To find our fuel, this is our fuel section, right? We'll just follow this line over to our next reference line. Does that make sense?
I'm sorry, where's the 6 knot headwind again?
Let's see if I can do this. Okay. Maybe it'll be a little bit easier now. Okay. So our winds are right here. Come on. Oh boy. Okay. So here's our winds on this side here. Okay. We came from 632, followed that up to our reference line. Okay. And then each one of the dots is 10 knots here on the side. You see that? So we're just going to go up kind of in between, following the contour of this line here and this line here. We're going to go up to about right there, which would be like a 7 knot headwind, right? Does that make sense?
Yeah.
Okay. From there, we follow it straight up to our next reference line, which will be this flight level 370 and above. Okay. Which puts us about right there. Can everybody see that point?
So when you're following the arc, is it just kind of your best guess?
Yeah, we're interpolating. So basically we end up on this old line here. Okay. From there, we follow that line all the way over to our next reference line, which is here. You see reference line on the bottom there. Problem with these charts is they've been copied and they're copies of copies of copies. So once we've got to this reference line over on this side, we will follow the contour depending on, you can see right here, it says flight level 350, which is the Morse code looking line, dashes and dots. And then there's a 370 line. Oh, I'm sorry. The 370 line is the Morse code line. The 350 is the solid line. So flight level 370, depending on our landing weight, we follow the contour of that line. So if our landing weight is less than 60,000 pounds, then we go this direction. If it's more than 60,000 pounds, we go this direction. Okay? So what is our landing weight? Okay, so to find our landing weight, go to our weight and balance chart and we minus our burn.
Is that the same as our zero fuel?
I was gonna say, yeah.
Okay, so.
So
We added it.
that's what we forgot. I forgot to add in our reserve.
Okay, so. Yeah, I don't understand what you're correct.
So it's our zero fuel plus our reserve.
Yeah. So our actual takeoff weight is a little bit heavier than we calculated by about 2,500 pounds.
So I'm getting confused now, so I got, that is a takeoff weight. Using that, I don't understand what you mean. How do I determine if I go up using this graph?
You're not using that graph with us.
Oh, okay, because everyone's looking at this.
No, we're looking at the weight,
Oh,
the weight.
okay.
Okay? Okay, so my bad, we're a little bit heavier than I thought. But it doesn't really affect much because we'd still be at 39,000 feet, I promise you that. Okay,
So we add 2,500, you said, or is it?
yeah, add 2,500, so take the reserve off, so do our max zero fuel weight, add 2,500 to that. What is that number?
Did you say 2,500 to our max zero fuel weight?
Yeah,
So is it 64A?
I don't know.
Or maybe I have
Is that,
max
what's
zero
yours,
fuel
your-
weight is 63.
or not our not our max zero fuel weight, our
Zero fuel weight?
57,083.
So it's 59,583.
So 59,000 pounds, just slightly below 60, and we're flight level 370, so we follow it back to about right there. Take that over, we're just below 5.2 thousand pounds. Does that make sense?
Follow the dotted one.
I'm
Yes.
following your line thing, but then where did you get the 2,500?
Yeah.
Just added that number.
So the 2,500, I forgot when we were doing our weight and balance. Our fuel, we figured out the 5750, right?
Right.
So this is our burn to our destination using our fuel estimate. On every one of our flights that we do, we always add a 45-minute reserve.
Okay, yes, that's right.
So our 45-minute reserve equals 2,500 pounds.
And that's the one in class, it's not really 2,500, but that's the number SkyWest uses, right?
That's the number we use,
Okay,
every one of our flights.
okay,
So adding that onto there, that puts us at
okay, gotcha.
7, what is it? No, 8,
Tires.
so
Yeah, and then the-
8250. So that's our estimated fuel. That's why we're doing one together first. Okay, you guys are keeping me on the straight and narrow here. Okay, 8250 for our estimated fuel.
So, you want us to change the 5750 to 8250?
I'm just gonna verify But it doesn't affect any of our numbers so far. So what's our weight and balance? What's our MTO?
Or what?
MTO, the takeoff weight.
62,883.
So 62,883.
Do we need to add the
Plus-
2,500?
Yeah, add the 2,500 to that.
$65,333.
So we come straight up here. Yeah, we'd still end up like right there, 39,000 feet. It just drops our our cruise capability by about 500 feet. So we're still above 39,000 feet on our cruise capability, but since we're heading
Low anyway.
right, so since we're heading and we need an odd number, 39,000 feet
2,000 down.
is what we choose, right? So
Basically, we just want to go the highest 2,000 we can.
yeah, because you burn more efficiently there. Okay, so now we've got our cruise capability, we've got our simplified fuel. What did we come up with? Just a hair under 52, so we'll round it up to 5,200 pounds. Did you guys see how I did that all? I'll try to draw it here on the board as best as I can. So you've got the box down here with the reference line in the center, right? So we came over to our trip distance of 632 nautical miles. We go straight up from 632 nautical miles to the reference line. From the reference line, depending on our headwind or our tailwind, we follow the contour of the line up to our headwind of 6 knots. From there, we take that up to our next box here. Okay, our next box has these. Okay, and this one says flight level 370 and up, right? So if I take this line up to that reference line, and then we have our fuel box here with a reference line down the center. We take that over, straight over to our fuel box. Now in our fuel box, we have a solid line and then we have this line that's like dash, dot, dot, dash, dot, dot, dash, dot, dot, dash. Okay, you guys saw that? So this line is 60,000 pounds and it's our landing weight, right? So since our landing weight is 59,000 pounds, we'll follow this 37,000 feet line. So follow the contour of that to our 59,000 pounds, and then over here, follow that directly over to the side, and we were just below 5.2. Is everybody good?
So what is the 5.2? That's the.
So 5.2, if you look on the right side of this here, it says trip fuel in thousands of pounds. 5.2 times 1,000 is 5,200 pounds. Okay,
And that's what we're running.
that's our simplified fuel burn, yes. Okay, now up above that box is another box. And what does that box say? Oops.
0.77.
It's our trip time. Okay, hours on the left, minutes on the right. So this is in hours. Minutes. Okay, you see a line here in this box. You see two lines, right? One says 37,000 feet, one says 25,000 feet. Okay, so if we follow this line, we went from this reference line, followed it up to here. If we just continue that line straight up to our 37,000 foot line, and then follow that out to the sides, tee it off out to the sides, that gives us our trip time in hours and minutes. So, let's see if we can do that really quick. Might need to zoom out just a hair more. Okay. 632 nautical miles, follow that up to our reference line here. 6 knot headwind, follow the contour of the line to about right there. And then we can just follow this solid line all the way up to our 37,000 feet and then tee it off. Basically right there. Remember, we're interpolating here. Interpolate my lines. So what is our estimated, our simplified trip time and fuel? So 5,200 pounds. Simplified time is
1.6 hours.
So each one of these dots is 0.1. So 1.6, is that what you said?
1.6.
So 1.6 hours, which is 90.
36 minutes. No, 3,600 minutes.
Yeah. Well, like,
An hour and 400.
yeah.
106 minutes.
So 1.6 hours.
96 minutes.
Okay, or you said 106 minutes,
Actually, 96.
96 minutes. Okay. That's what we're estimating. That's calculating for our average winds and heading. What was our estimated burn again? 5750?
Yeah.
So 5750, what's our simplified fuel?
52.
5,200. So just averaging it off of our cruise winds, supposedly, and I don't know how it's possible, we're ending up with 5,200 pounds.
And we would go off this simple fuel.
Yeah, so we're going to use simplified fuel. It's a little more accurate.
It's
So,
unbelievable.
yeah.
Wow, it just seemed like we did like all those calculations and then, well, we calculated the wind.
So I'll explain it just a little bit here. So the reason why it seems counterintuitive. So we're basing 4,000 in our first hour, 3,000 in our second, and everything after, right?
Mm-hmm.
That's how we get our 5750. What did we just say about altitude affecting our
Can increase
Better performance.
better performance the higher we
The
go?
less the feather pressure, the faster you can go.
Exactly. Okay. So that being said, if our performance, we're using this based off of our some random number, probably I'm guessing going to be somewhere in the 33 to 30,000, 35,000 foot range. That being said, those are fuel burn. These, we just use these to get us in that ballpark. Okay. So if, let's say that this is just at 33,000 feet. Since we're getting better performance and a slight, very minor headwind, our performance, when we calculate for our altitude and for our wind speed. Because we're flying at a higher level, I'm guessing, that's why we're getting 5,200 pounds.
Instead of needing more,
Instead
because
of-
we have the headwind.
Well, no. Now, the headwind is a very minor factor because it's only 6 knots. But the altitude is going to affect our fuel burn a lot more. So I'll show you the chart really quick.
So that 4,000,
Right.
Okay.
4,000, 3,000 doesn't take altitude into account. It's just an average overall.
Yeah. That's just like saying, me, just to get us somewhere in the neighborhood. So let's take a quick look at the difference between, let's just use our ISA chart really quick and let's look at the difference in fuel per hour. Let's get to our cruise charts. So our cruise, what was our takeoff weight again?
I think it's 65333 if we change
Okay,
it.
so let's just say that let's look at 66,000 feet at ISA plus 5. Or 66,000 pounds, 39,000 feet at ISA plus 5. And our cruise, if you look up here in this key, this is telling us the information in the box. So the first number is our N1 speed, or our percent of N1, I mean, sorry. The second number here is our pounds per hour per engine. Times 2, because we have 2 engines, right? That's how much fuel we're burning per hour. So that comes out to 3,000.
3048.
What was that?
3048.
3048. That's at 39,000 feet. Flight level 390. Let's look at 33,000 feet. 1715. So that comes out to what? 34,
30.
30. You see the difference there? So let's just say that our whole trip, we're burning 34,000 or 3,430 pounds per hour. So half that, right? So
1715.
oh wait, no. Yeah, 50. 5145, and this one, so that's a pretty good, this is a much more accurate number, right? Just because it's accounting for our fuel burn at altitude and our wind speed. So a headwind is going to reduce our performance a little bit, right? But not by much. Okay. So yeah, that's why you want to use your simplified fuel. What time is it? 7:17. You guys want a break?
Yes, please.
All right. How long of a break? You guys need to go to dinner? You guys want to order pizza next time or something so we can? What do you guys want to do?
Pizza next time, down for me.
Dan's really gonna order pizza next time.
So let's do a 30-minute break, I guess, and then you guys can go and get your food, or I can just like pick up chicken, whatever you guys want to do, and then we can only take, or then we could do like a 15-minute break to